Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today, we'll be simply explaining how to subnet IPv4 networks. This is the second video in this series on subnetting. Now, in this scenario, we'll be subnetting a series of network segments that are generally smaller. We'll also see why it's important to start by putting your subnets in order from largest to smallest. Before we begin, please take a moment to subscribe to my channel and to like this video if you find it useful. Now, this video is the second in a series of videos that are designed to show how subnetting is achieved. In each video, we'll be looking at a different enterprise network scenario with a particular addressing scheme requirement. And we'll go through a step-by-step process of solving each case. Now, what we are actually doing here is called Variable Length Subnet Masking, or VLSM. We're actually creating multiple subnets of variable lengths in order to accommodate specific requirements. VLSM actually makes more efficient use of IPv4 address spaces because you create subnets with sizes comparable to the requirements. VLSM is an important part of what we call classless interdomain routing, or CIDR, which is an important method of allocating IP addresses for IP routing. I won't talk more about that right now, but I'll post another video that talks about these concepts in more detail. For now, it's sufficient to say that these techniques allow us to use subnets of various lengths. However, and this is the key point here, when you use VLSM, you must subnet the networks in decreasing size. If you don't do this, subnetting will fail. In this video, I will deliberately put the subnets not in order of decreasing size so we can see when and how subnetting will fail. Now, for today's scenario, let's say that we are given an address space of 10.10.20.128/25. For this address space, we are asked to create 3 subnets of various sizes for an enterprise network. These subnets will have an expected number of hosts as follows. Subnet 1 will have 55 hosts, Subnet 2 will have 27 hosts, and Subnet 3 will have 4 hosts. Now let's take a look at our original address space that we were given, which is 10.10.20.128/25. And let's take a look at this address range with the full subnet mask written out. The subnet mask is 255.255.255.128. Now let's take a look at this again, but this time we'll represent the last 2 octets in binary. We can see that with this subnet mask, we reserve 25 bits for the network address, and it's the last 7 bits that are defined as the host addresses. How large is this address space? Well, 2 to the power of 7, and 7 are the number of host bits, give us a value of 128. Now, the first thing to do is to list these subnets in order from largest to smallest, based on the required number of hosts. However, to demonstrate why this is necessary, let's not do it that way. Let's put the subnets in the following order and see what happens. We'll start with subnet 1 with 27 hosts, and subnet 2 with more hosts, 55 hosts, and subnet 3 with 4 hosts. Let's do it this way and see what happens. Now next, based on the required number of hosts per subnet, we must choose a subnet size. Now remember, the sizes of our subnets are always 2 to the power of x, where x is the number of host bits. Now I've already gone in and chosen the most appropriate subnet size for each of those subnets. That number in red you see is actually the number of host bits that we're going to use. So automatically, you know the number of network bits. And thus, you know the subnet mask that we will be using for each of these subnets. Now notice for subnet number 3, where we have 4 hosts, we can't use a subnet mask with 2 host bits because that would give us 4 addresses. But remember, the network and broadcast addresses are reserved. So we would have only 2 usable host addresses. So we need the next largest subnet size, which requires 3 host bits, giving us a full size of 8 host addresses. So let's start subnetting our address space. Take a look at the details of subnet number 1. We have 27 hosts, we have 5 host bits, which gives us a range of 32 addresses. With 5 host bits, that means that our subnet mask in binary is composed of 27 ones and 5 zeros, like so. In dotted decimal format, that comes to 255.255.255.224. Now to start subnetting, we take our initial address space of 10.10.20.128 and we'll write it out with the last 2 octets in binary, like so. Then we put in our subnet mask for our first subnet, which is 255.255.255.224, and we'll also represent this with the last 2 octets in binary, like so. Now, we draw a line at the point where the subnet mask tells us that the host and network portions are split. Our subnet mask says that the first 27 bits are the network portion and the last 5 are the host portion. Next, we start by writing out the network address. Remember, this is the address that has all host bits set to 0. Next, we write out the first host address. This is simply the network host address plus 1. Now, it would make sense next to look at the last host address, but that's not always that easy. It's easier to determine the broadcast address first. Remember, the broadcast address has all the host bits set to 1, and here's what it looks like. Finally, we can now take a look at our last host address. This is now easy to find because it's the broadcast address minus 1. So now we found all of the important addresses in the process of our first subnet. We have the network address, the first and last host addresses, and the broadcast address. The only thing that's left to do is to write them out in dotted decimal format, and here they are. Now, one thing to notice is that the network address is actually exactly the same as the original address space that we were given. This is simply because we're starting at the very beginning of that address space. However, the address is actually not the same because our subnet mask is different. The subnet mask is a smaller subnet mask, meaning that the resulting subnet is really a subset of the original address space we were given. So that's the first subnet we've created. Now remember, we deliberately started with a subnet that wasn't the largest in our list, so we are deliberately making a mistake. We won't see the impact of this in the first subnet we create, but we'll see it in the very next subnet. So let's go on. Here we see again the size of subnet number 2 is 55 hosts, deliberately larger than the first one. For this subnet, we need to use a subnet mask that provides us with 64 hosts. That means that we need 6 host bits. Looking at the subnet mask, we get 6 zeros at the end of the host portion, which translates to a subnet mask of 255.255.255.192. Now previously, for the network address of our previous subnet, we used the network address of the address space we were given because we started at the very beginning of that address space. What network address are we going to start with here? Well, we always use the following rule. The network address of this subnet is the broadcast address of the previous subnet plus 1. So for our first subnet, we had a broadcast address of 10.10.20.223. Adding 1 to that, we get 10.10.20.224. So this is our network address for subnet number 2. Now once again, we use our network address and our subnet mask, and we are representing the last 2 octets in binary. We then draw a line separating the host portion from the network portion based on the subnet mask. Now this is where we see the problem with not putting our subnets in order of decreasing size. Here we see that if we try to get our network address, we get this. We have a 1 in our network address. However, by definition, we can't have a 1 in our network address. It should be all zeros. But our network address is, by definition, 10.10.20.224. The problem is that the IP address of 10.10.20.224 can never be the network address of a network with a subnet mask of 255.255.255.192. It is for this reason that we need to put our subnets in order of decreasing size. This way, for each subsequent subnet, this red line that separates the network portion from the host portion will move to the right every time as our subnet mask gets smaller. So our subnetting has failed. At this point, what we should do is go back and start again, putting the subnets in proper order. But we'll do that in our next video. For now, this shows the importance of putting those subnet sizes in decreasing order. Now, this is just one video in a series of videos that I'm posting that will have several examples of how subnetting is performed, with different examples every time. Subnetting is a huge topic, so look out for more of my videos covering the various aspects of subnetting. I hope you found this video useful, and if you have, please click that thumbs up button. If you'd like me to address other related topics, feel free to let me know in the comments below, and please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this video has been helpful for you, and I'd like to thank you for watching.